Water is flowing in a tube as shown in figure. Okay, there's a water, density of water, rho W. Specific gravity of liquid present in U tube is 12. Okay, this will have sigma. Later on, I'll replace it. Fine. Okay, we'll do one thing. We'll give different colors so that you'll understand. It's a very good problem. They just again, see, we don't have anything. Equation of continuity, Bernoulli less time, finish over. Nothing big. So don't get scared anything here. Okay, this is the some liquid of density sigma it is. Now, okay, this is the water which is flowing here. Okay, there's a density of same water will flow here. Rho W will take it. So we'll take some points for our reference. 1, this is 2, this is 3, this is 4. That dots I'll eliminate. Okay, now it will be two liquids are there, density sigma. Okay, this is that particular point. Okay, now we have almost all the data in front of us. This distance is what? I'll call it as h. This distance, I'll call it as h naught. Okay, let's get into the problem. First, what is the flow rate at 1? I don't have an answer. We have to verify it. I don't have answer. Okay, let's get into flow rate at 1 should be equal to flow rate at 5 and 6 Q1 should be equal to flow rate at 1 should be equal to, so 3, 4 I put it, so 5, 6 I'll write it here. This is 5, this is 6. So first, shall I proceed like this? A1 V1 should be equal to A2 V2. And what all the liquid comes here, so what will happen to this amount of liquid? Some amount of liquid will pass here. Some amount of liquid will pass here. What is the question that is asked? What is the velocity of this emerging liquid? That's the thing. So, so according to the flow rate idea, so it should be A1 V1 should be equal to A2 V2. Fine. So we don't know A1 V1. We know only A2. A2 is how much? 6 centimeters square. We'll write the data. Then, okay, next again equation. A2 V2 should be equal to sum of A5 V5 plus A6 V6. We know A6 V6. Okay, fine. And we know A5. So A5 is how much? Oh. Are you able to see all of you?
Yes, sir.
Just wait some screen. Okay, fine. Yeah. Screen not working. Are you able to see?
Yes, sir.
Yes,
Okay.
sir.
Yeah, fine, fine. Yeah. Now, A5. A5 will write 4 centimeters square. A6 is how much? 1 centimeter square. I think we have some data like this. This is the thing. What is our question? We have to somehow calculate the V5. It is. So V5 is V, which is unknown thing. Our goal is to find out this V5. The only thing is unknown. So we know A6 and V6. We know A5. We know A2. So somehow what happen if I can get V2, I can get 1. So to get the V2, we know A2. A1, V1, that we don't know. Velocity at point A. VA also, V1, we know it. What all the data's velocities we know, we'll write on this side. V1 is root of 20.2 centimeter per second. Sorry, meter per second it is. V1. V2 we don't know. A2 we know. Okay, let's get into. So this is about the thing. Okay, let's write the Bernoulli's equation between 1 and 2. Is it okay? First, E1 should be equal to E2. So this should be P1 plus, they are at same energy level, no? So density of water, V1 square by 2, P2 plus U plus rho W, V2 square. So P1 plus, keep it in hand like this. Then what is the pressure at 3 and 4? Should be equal, no? Because they are on same horizontal line. Pressure at 3, pressure at 3. What is the expression for pressure at 3? So we'll do one thing. I'll write the equation like this. P1 plus density of water G H naught plus H minus P3 equal to 0. I'm asking you to write manometric equation from here to here. P1 plus rho W G H naught plus rho W G H, because what is the density here? Everything is rho W here. Okay, similarly write manometric equation other side. P2 plus rho W G H naught minus sigma plus sigma GH minus P4 equal to 0. So what is the pressure at 3 and 4? Should be equal. They are lying on same horizontal line. So therefore, what is P3 should be equal to P1 plus rho W G H naught plus H should be equal to P2 plus rho W G H naught plus sigma GH. Rho W G H naught will cancel out. So therefore, I can, the equation 1 here P1 okay, there's the equation 2. So do we know P1 minus P2? Yes, substituting P1 equal to substituting 2 in 1. We know V1. From that, what happened? We'll get the V2. I'll solve it. Put 2 in 1. Or else we'll write one more step. It'll be easier. I'll call this as equation 1. This will become P1 minus P2 equal to sigma minus rho W GH. Put 2 in 1. So equating that sigma minus rho W GH should be equal to, okay, I think we know V1, we know sigma and rho W all, and we know H also. Substituting will get the V2. That value of V2 I'll substitute here. Then I'll get V5. Fine. Can you solve this later on? I'll go for the next question. A complete problem is visible. See once. Solve for V2. So then what is V5? V5 should be equal to A2 V2 minus A6 V6 by A2. That V5 is what? B. Okay, no, so some questions are there like this with inverted on this one. So there's a method what you should apply. I'll scroll down. Read this question.